Good afternoon and welcome to Design Master Training. My name is David Robison. Today we're going to be looking at the electrical design triangle. Let's do a quick tech check. Let me know in the chat box where you're tuning in from. We've got Rob from Spokane joining us. Let's go ahead and shout out where you're tuning in from. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497, and our email address is support@designmaster.biz. So today I am going to be teaching you a framework that we call the electrical design triangle. It's a framework for analyzing your electrical design process, specifically within Revit, and just putting a framework together that you can use to figure out how you can do your design in a way that's going to be most efficient, that's most productive, that's most helpful for getting your designs out the door in a timely manner. So the electrical design triangle, as you might imagine, is a triangle. So I'll go ahead and draw that here. Looks a little bit like that. It's got three sides. So there are three sides to your electrical design triangle that are really going to influence how you do your design. On one side, we've got the single line diagram. And that's obviously the diagram you have that's laying out where all your panels and transformers are, how they're connected to each other. It's diagrammatic, and it's not necessarily related to your 3D model. We've got the calculations, and this is everything from your panel schedules with your loads on your circuits, your feeder sizing, voltage drop, fault calculations, any sort of arc flash or selective coordination that you're doing, lighting calculations, that's all on that side of the triangle. And at the base, kind of the foundation of the triangle, we have the Revit model itself. And so those three sides of the triangle are what you use for your design, and you can use this framework to analyze your design process. So we're going to walk through those three different sides, talk a little bit about each of them, and then work through some examples of how you use that for your design work. The first side of the triangle I want to look at is the Revit model. Again, this is the foundation of what you're doing. Since we are talking about Revit, it's really important that you understand how Revit works when doing modeling in Revit. There's a lot to know about Revit that's not electrical related, but the more that you understand about how Revit works, the more successful you're going to be with your electrical design. So you really want to dig into Revit and make sure you're understanding all of the different components of Revit, not just the electrical stuff, but all of the other pieces that it has included as well. There's two parts of Revit that I want to highlight in particular. The first are families. These are the building blocks of your model. This is where you define what a receptacle or what a panel looks like. You want to be comfortable using families. You really want to be comfortable opening them up, inspecting them, modifying them, so that you have a good understanding of how to create the families, how to modify the families. The more comfortable you are with your families, the more successful you're going to be in Revit in general. And so the more successful your electrical model is going to be as well. And like I said, not an electrical concept at all. This is strictly Revit modeling, but it's an important concept that you want to understand. Another portion of Revit that I want to highlight are shared parameters. Revit uses all of this for their labeling, for their schedules. It uses them for their families. You can use it to drive geometry and what things look like. You really want to be comfortable creating shared parameters, working with them, using them for labels and in schedules. You can put them in annotations on your drawings. The shared parameters are really important for putting together a model that's properly documented. And again, not an electrical concept at all. This is strictly Revit, but you want to make sure you have a good understanding of shared parameters and families. If I had to highlight like the two most important Revit things to understand, it would be those two pieces, families and shared parameters. And then Revit has obviously all of its electrical features in it as well. Things like panels and transformers. You want to understand that those and families are defined as electrical equipment. You want to know how to connect your equipment together using the power commands in Revit. Revit does have panel schedules built in that work fairly well. You want to make sure that you're using the panel schedules, that you get the loads from your devices into the panel schedules, that the panel schedule is one that you're comfortable using in your company. And then we've got all of the stuff that all the devices that have loads on them. You've got receptacles, you've got light fixtures, equipment connections. You need to define those in Revit. You need to define the families so they have the loads either in the family or in the instance, depending on how you're doing that. You want to be comfortable circuiting those devices back to the panels. So there's a lot in Revit itself that you just need to understand about electrical work. You should have a good understanding of all of this. There's probably always more that you can learn. We could do multiple sessions just on using Revit itself for electrical design, so we're not going to belabor this point anymore, but I do want to just point out that the Revit model is the foundation for what you're doing, particularly when you're trying to do electrical design in Revit. You really want to understand how Revit works. The next side of the triangle that we'll look at is the single line diagram. So the single line diagram is the conceptual view of your design. We're going to go ahead and take a look at how this is done in Revit. So I will pull up Revit here. And the first question you need to ask about your single line diagram is, where does this even live? There's lots of places you can put your single line diagram. It used to be that we would have our single line diagram in AutoCAD, because that's where we did all of our drafting. You can continue to do that. It's not going to be your most efficient workflow because you're having to transfer back and forth between Revit and AutoCAD. So there's a lot of transferring that has to happen, and you're not working in the same program, and it's never going to be as smooth as if you have it in Revit itself. This is the Revit sample project, and they cut a section of the building, and they have kind of the beginning of a single line here. And I like to point this out just because it makes me laugh a little bit, because they're kind of trying to imply, I think here, that maybe you could cut a section and have that work as a single line diagram. But as soon as you try to do anything interesting or complicated, this is going to break down completely. In this example here, they have a couple feeders that they drew in, but they didn't draw the rest of them because it's starting to get a little tedious. Also, they've got maybe a third of their actual panels laid out here that all just happen to be laid out really nicely so that they look nice in this view. An actual electrical room is not going to be stacked like this and not going to look this neat and tidy. So it's kind of cute that they put this here, but the idea that you could actually cut a section and have it work as a single line diagram immediately falls apart in the real world if you try and use it that way. Another option that some people do is that they take their plan view and they'll go off to the side and they'll do their drafting for their single line diagram there. That can start to work. You're fighting Revit a little bit there. You can have some labels between the plan view and the single line, and you can get some stuff to update automatically. But you're really fighting Revit at that point, trying to use a 2D plan view for a diagram, which is not really where it belongs. The best place where you really want your single line diagram is you want your single line diagram in a separate drafting view. With Design Master, we have all of the tools available to make this happen so that your single line diagram can show up in the drafting view for you. So you really want to get your single line diagram in your drafting view. You want to create it using Design Master so that you have all of the tools and functionality that we have available for you. In the drafting view, again, going back to our Revit model and understanding Revit, the more you understand about Revit, and you can have these pieces in the Revit drafting view work nicely for you. We have this set up so this family, you can resize this panel so that you can get the right size, so you can adjust this bus bar and get the graphics looking how you want it. Because again, the single line diagram is a diagram, it's a representation of the model, so you need to have it, partly it's just making it look right. And the better you have your graphics set up, the better families you have, the more success you're going to have with that. So you want to be able to change the appearance. And we've got this set up so we can adjust this transformer. Maybe we don't want to have the box around it. Or maybe we want to have it be dashed, so we can swap it out for a dashed graphic. Or we could select it and run one of our commands to modify the graphic and actually change it to a transformer box without a box. And maybe we don't want to have the ground either. So we'll do a transformer, no box, no ground. An important part of having your single line diagram be productive is to have consistent graphics. I work with obviously lots of engineers across the country, and the joke that I always tell is that if I ask 10 engineers what their single line diagram looks like, I'll get 15 answers back. Because not only is it different between every single company that we work with, companies will have multiple standards depending on who happened to be doing the drafting that day or how they were feeling at the time. And trying to be productive when you're having to worry about your graphics all the time is going to slow you down. So you want to have consistent graphics. Again, Design Master is going to help you with this so that when you put in a device, it's going to tell you what device, it's going to have the graphics available for you. So going back to all those families that we have in Revit, Design Master has tools to put together libraries of family so that when we go and insert a new device, say we want to put in another panel here that's not inserted on the single line yet, we have a list of graphics available to us so that these graphics are going to match. Out of the box, Design Master comes with a set of graphics. We realized that these aren't going to match exactly what you normally do. We tried to come up with something that looks reasonable so that it's kind of going to match what you might want it to look like. And if you want to, you can modify our families so that they more closely align with what you would like your single line diagrams to look like. You can also expand it to add additional graphics. Again, just using Revit families and linking it with our software so that it's in our library so that everyone's using these so that you create something new. If you add a fire pump graphic, that fire pump is then available for everyone in your company. You're not having to recreate that. And then finally, and this is where Design Master really comes into play, is that you want to have your single line diagram consistent with your model so that changes to the model are reflected in the single line diagram. So that you're not having to constantly chase pieces and you change something in one spot and then you have to go change it somewhere else. For example, if we come over here to this section view, this would more likely be on a plan where you've got devices labeled. So if we want to change the name of a panel, I can take this MDP1, say we're getting rid of dashes, we'll call this MDP1 without a dash. It's a trivial change, but now you got to change it here, and you got to change it in the single line as well. So we make that change here. It's going to update in our section view, so we've got the MDP1, but then over in the single line, it updates here as well. So you want to have it so that changes in one place are affecting both the model and the single line at the same time. And then the final side of the triangle is going to be the calculations. Now, the calculations are obviously a very important part of what you're doing with your electrical design. This is where you're assigning loads to circuits, making sure those circuits are on panels, how big your feeders are. There's a lot, obviously, of your electrical design is in the calculations itself, making sure your voltage drop is acceptable, checking your short circuit calculations, and getting your AIC ratings correct. We'd like to think that we have a single model and it's really nice and clean and we don't have to worry about it. But the reality is that the calculation models tend to get a little bit messy. To begin with, you're going to have some stuff in Revit itself. Revit can do loads on devices. Revit can do the panel schedules pretty well. It can transfer those loads between panels. It can do a panel schedule. So you're going to be doing some of your stuff in Revit. And then maybe you step out into Excel to do a voltage drop or a fault calculation or something of that nature. So a lot of people have their Excel spreadsheets and you can step outside to do that. Though the reality is you're not using one Excel spreadsheet. You probably got 3, 4, 5, 10. You've got a lot of Excel spreadsheets, and again, you got to keep that link between your Revit model and your calculations. So that can be a little bit time consuming to work on that. There's other places you can have calculations. Mike Holt has all of his tools available. So you might have some of those that you're using for some of the calculations off to the side. There's SKM, Easy Power, and ETAP. Obviously, you might be using some of those calculations for doing stuff. You've got your lighting calcs, either in Elam tools or visual, depending on what you're doing. And there's just a lot of different places you can do your calculations. For our purposes, what we want to do is push all that to the side and have Design Master do as many of the calculations as you can. I'm not going to say that you will only use Design Master, but certainly it should be the focus of your calculations. You are going to definitely do some stuff in Revit. It will still exist. You might need to go to an Excel spreadsheet for a certain calculation. You might still use Mike Holt to do some of your checking. We have been expanding the calculations that we have in Design Master. We can do arc flash. We can do selective coordination. but I'm not going to say we can do everything that SKM or Easy Power or ETAP can do. If you get into some of the more complex electrical calculations, there's still a place for those. And we're not at the point where we've totally replaced them yet. So if you need to, you can step out to those programs. But that should be, an edge case. Most of your calculations, again, are going to be done in Design Master. We don't have anything for lighting. There's still a place for Elim tools or visual, however you want to do that. But you want to keep as much stuff in Design Master as possible. So having talked about all of those different options, let's go back to this design triangle here. We've got the three sides of the triangle, and I was kind of alluding to this as I was describing them. These three sides are not independent. They are all related. And you want to make sure that changes in one are going to be reflected in the other places. So if you go to your single line diagram and you change a panel name, you're going to need to have that changed in your Revit model as well. So you need to have changes from your single line diagram, update the Revit model. In your Revit model, if you add a new panel, you need to make sure that it shows up in the single line diagram. Same thing with the calculations. That if you add a new panel, that needs to show up in the Revit model and in the calculations. If you upsize something in your calculations, the Revit model needs to be affected. Also, the single line diagram. If you're changing a feeder size, that label needs to be updated. In the single line diagram, if you're changing your sizes, you want to have that impact the calculations as well. So these three sides of the triangle all are playing off of each other, and you want to have all of them as linked as possible. Before you were using Design Master, you probably had 50% of your stuff, done in Revit, and then 50% you were stepping out into Excel spreadsheets or SKM, and had a single line diagram was separate. The goal with Design Master is to get that percentage bumped up as close to 100% as you can. And again, I'm not going to promise that you can get everything done using Revit and Design Master together, but if you can get that percentage up to 80% to 90%, that's where you start to be successful and productive with the software. So that as much as possible, you've got it all in one program so that when you make a change in one place, it's going to those other places automatically. And then for that 10%, you still might have to step out and do some design separate. For some projects, for the simpler things, for just run-of-the-mill commercial applications, you might be able to get 100% of your stuff in Design Master and Revit. And that's obviously going to be your most successful way, your most productive way of using the software. So let's jump back into Revit and just work through how these sides of the triangles work together using Design Master. So let's take a look at voltage drop. I'm going to pull up my voltage drop schedule here. We've got my schedule. It's probably a little tiny, but we have a panel here that exceeds the 3% on the feeder. So we would want to upsize that feeder so that we drop our voltage drop. And it's actually the panel above where we really need to make the adjustment. So in Design Master, we can run the panel edit command. And this is where we're defining everything about that panel, including your feeder size. So we can go from 250 kc mil wire, which is a 250 amp wire. We'll bump it up to a 300 amp wire, 350 kc mil. And that will resize that wire. And then we need to redo our calculations so that it will update what happens on the single line diagram. It updates what happens in the voltage drop. And it updates what's happening in the model as well. It is asked occasionally, why don't we do these calculations automatically? And the answer, as we're waiting here, is that if we did them automatically, your next question would be, well, how do I turn the automatic calculations off? As your projects get bigger, there is a little bit of just time taken to actually do the calculations, just because we're doing a lot of calculations when we run that. But we'll see here that we've got the voltage drop for EP2 down to 2.77. And we've got the new wire size, the 350, listed here in our voltage drop schedule. So in our calculation side of the triangle, we've got that noted properly. If we come over to our single line diagram, gotta track down that panel. That was panel PP2B. We have the new feeder size listed here. So now it's a 300 amp feeder. So that was updated automatically. So we've got those sides linked so that changes. We first went to the Revit model, updated it there through Design Master, calculations updated, and the single line diagram updated. So we're making the change in one place, and all three sides of our triangle are updating at the same time. And that's the goal that you want to have for when you have things that belong in all three sides of the triangle. You can also use the electrical design triangle to analyze how you need to model something else. For example, say we need to add a meter to our project. Going back to our triangle here, the question is, if we're going to add a meter, where does that go? We've got the single line diagram, we've got the calcs, we've got the Revit model. Well, clearly the meter needs to show up on the single line diagram. So we want to have a meter here. There's my meter. But that really doesn't enter into the calculations at all. That it's just something that's going there. You need to notate that you're having it for, you want to have it on the single line diagram, but the calculations, your voltage drop isn't going to be affected by the meter. So it's not actually going to show up here at all. And depending on what you're doing, you may or may not show this in the Revit model. You don't often drop in a little device showing the meter because you don't really need to locate that on the Revit model. It doesn't matter in 2D or 3D where that is. So you might not even show that here. So you can use the triangle to think about, okay, where do I have to model this to get it modeled properly? So if we're doing it just a meter, all it really matters is the single line diagram. So we can jump back to Revit, and we can go to our single line diagram. If we want to add a meter, you can use Design Master. Again, consistent graphics. You do this through Design Master, so you've got graphics that are consistent throughout your projects and they're easy to find and use. We're going to add a graphic. We're going to add a meter to this feeder. We'll put that meter on the feeder. So we've got the graphic here. But again, it doesn't really impact our calculations or our Revit model at all. So it's showing up just on the single line diagram. In some cases, that's okay. That's just the only place it belongs. So you can use the electrical design triangle to really think through systematically where you need to do the modeling of this device. Another thing, and this is a question we get a lot, is what do I need to do about a bus gutter or a bus duct? Where does that belong? So draw the triangle. We've got the single line diagram. We've got the calcs. We've got the Revit model. And a bus duct or a bus gutter is going to have actually a lot of different pieces. And this will help you think through how it's going to work out. So you need to have it on the model, on the Revit model. So you need to have a bus duct family or a bus gutter family or whatever you're creating. So you need to have a family. So this goes back to understanding Revit, making sure that you're creating your families, that you know how to create a family. That if you need a bus gutter family, you know where to go find one. You know how to modify it so it looks like what you want it to look like. In the calculations, you then need to make sure that this bus gutter is being calculated properly. Typically, that's going to include the length of the bus gutter and the length to the different pieces from the start of the bus gutter to the location on each floor and then to the devices. So you might actually need to model it as multiple pieces on, if you've got multiple floors here, you might have a device on each floor that you then connect to each other. And so you can get those on the floors, you can get the lengths right. You want to get your impedances correct. And so you can use Design Masters to set the impedances because the impedance of your bus gutter is going to be different from the impedance of your wires. And then on the single line diagram, you need to get the drafting correct. So maybe, you're going to put in a family that looks something like this, and maybe you've got little disconnects that you connect to, and then your feeders out to the rest of your piece, to the panels or whatever is being fed by that bus gutter. On the single line diagram, you might have it linked to this first piece in the model. This might link over here. You might draft in the rest of the pieces. You might not link the other pieces of the bus gutters. You might have stuff in your Revit model that's not necessarily showing up in the single line diagram, depending on how you want to handle that. So the electrical design triangle helps you to think through how are you going to model something like a bus gutter in your project. How are you going to make sure the Revit model is correct? How are you going to make sure your calculations are calculating properly? And how do you make sure that the single line diagram shows it properly as well? So that is the electrical design triangle. It's the framework that we have for analyzing your electrical design process, making sure that your single line diagram, your calculations, and your Revit model are linked. You can use Design Master for that link so that you can use our software to have all of those pieces connected to each other so that changes in one are going to impact changes in the other, and you're not having to make the change in each place. That we actually have workflows built into the software to make those linkages for you. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.